Welcome! Today we are tackling, well, the biggest topic imaginable. We're talking about everything. The whole cosmic shebang, from how unbelievably big it is to how it all started and where it's all going. All right, let's jump in. So, to even begin to get a handle on the cosmos, you need a starting point, right? A you are here map. And for us, that journey has to start right here, at home. So for this first part, we're going to do a cosmic zoom out. It's really the only way to get a feel for the jaw-dropping, mind-bending scale of it all. So get ready to feel very, very small. Okay, here we are. Planet Earth, our little blue marble. As far as we know, it's the only place with life, which makes it pretty special. But in the grand tour we're about to take, this is just our launching pad. Okay, let's take that first step out. We're now looking at our immediate solar neighborhood. These are the stars that are, relatively speaking, just around the corner, within about 20 light years. Think of them as the houses on our cosmic street. Now we pull back even more, and our little street of stars? It turns out it's part of a much bigger city. This is the local group. It's a collection of galaxies, including our own Milky Way, and its huge neighbor Andromeda, all kind of held together by gravity. And if the local group is our city, well, it's just one of thousands inside a vast cosmic state, or what scientists call a supercluster. We're talking about structures that contain millions of galaxies. The scale here is already starting to get a little hard to process, right?
And here we go. This is the big picture, the cosmic web. These are called filaments, these unbelievably long, glowing threads of superclusters that stretch across the entire observable universe. Everything, our galaxy, our sun, our planet, is just one tiny speck of light in this immense structure.
So, just how many of those cities, those galaxies, are out there? Well, the current best estimate is at least 100 billion galaxies. And remember, each one of those has billions, sometimes even trillions of its own stars. It's just wow. Okay, so our minds are officially blown by the sheer scale of it all. But looking at this incredible structure, it just begs the ultimate question. Where did all of this come from? How in the world did it all start?
And that question takes us to part 2. We're going to rewind the clock all the way back to the very first moment. The instant of creation itself.
And the best explanation we have for that moment is, of course, the Big Bang. The idea is that about 13.7 billion years ago, everything we know, all of space, all of matter, all of energy, burst into existence from a single point. A point that was unbelievably hot and unimaginably small.
Now, what's just wild is how quickly everything important happened right at the beginning. I mean, in the very first sliver of a second, there was just one superforce. Then, poof, the universe inflated faster than light itself. By the 3-minute mark, you have the first building blocks, hydrogen and helium nuclei. But then it took another 380,000 years for things to cool down enough for that cosmic fog to clear, and for light to shine free for the very first time.
So fast forward 13.7 billion years to today. What is the universe actually made of? Well, here's the kicker. Everything we can see, every star, every galaxy, you, me, this planet, all of it is just 4% of what's out there. The other 96%? It's a total mystery. It's made of invisible dark matter that acts like cosmic glue, and this strange dark energy that's actually pushing the universe apart faster and faster.
So, let's just focus on that tiny 4% that we can actually see and understand. What are the things that light up the darkness? What are those cosmic engines that build everything we know?
Yeah, it is time to talk about stars, because they're not just pretty lights in the sky. They are the actual forges. They're the factories that create the very elements that make life possible.
So let's follow the life of a smaller star, one kind of like our own sun. It all starts in a huge cloud of gas and dust. It then spends most of its life just steadily burning hydrogen. But when that fuel starts to run out, it swells up into a red giant. Finally, it just puffs away its outer layers, making this beautiful thing called a planetary nebula, and all that's left behind is its tiny, super-dense core, a white dwarf.
It's a pretty graceful exit.
But the really big stars?
Oh, they live fast and die hard. They burn way hotter and faster, swell up into these enormous red supergiants, and then it all ends in a heartbeat. The core collapses and the star explodes in a supernova, one of the most violent events in the entire universe. And what's left? Either an impossibly dense neutron star, or if the star was big enough, a black hole.
Now, why does any of this matter to us?
Well, here's the most profound part. Those supernova explosions are what scattered all the heavier elements across the galaxy. The carbon in our DNA, the oxygen we're breathing right now, the iron in our blood, every bit of it was forged inside a massive star that died billions of years ago. We are, quite literally, made of stardust.
And those stellar leftovers, they're just places of pure extremity. A white dwarf is so dense that if you had a tablespoon of it, it would weigh 3 tons. And a black hole, that's a whole other level. Its gravity is so intense that once you cross its edge, the event horizon, that's it. There's no coming back, not even for light.
So, okay, stars have a beginning and an end, a life cycle. But what about the whole show? What happens to the entire universe eventually? What's its ultimate fate? This brings us to our final and maybe most profound question. We've looked at the beginning. Now let's take a look at the possible ways it could all end. Right now, there are two main competing ideas. The first is what you might call the big freeze. In this scenario, dark energy just keeps pushing everything apart forever. The universe gets colder, darker, and emptier until the last star flickers out into an endless night. The other possibility is the complete opposite, the big crunch. In this version, gravity eventually overpowers dark energy, stops the expansion, and pulls everything, all the galaxies, all the matter, back together into one single, hot, dense point, maybe even starting a new Big Bang. So, which is it going to be? A spectacular, fiery end and a big crunch? Or a slow, cold fade into the big freeze? A bang or a whimper? Our entire cosmic story, born in a brilliant flash of light, all comes down to that one question. And honestly, we don't know the answer yet. But the fact that we can even ask it, that we, a bunch of organized stardust, can look up and ponder the fate of everything, that to me is the most incredible part of this entire journey. Thanks for joining me.